Hi everyone and welcome to my channel where we dive into the world of tech with a huge focus on DevOps. Today's video is the first episode in a series dedicated to Docker. Docker as a technology has completely redefined the way developers approach the deployment of applications and making sure that applications remain consistent regardless of the environment they're deployed to. Without further delay, let's get straight into it. But before we go into what Docker is, let's look at what existed before Docker. Before Docker, applications, software, and websites were deployed to and managed using virtual machines. So virtual machines serve as a robust technology that allows a single physical server to host multiple isolated operating systems. Each virtual machine operates with its own complete version of an operating system, applications, and library, effectively mimicking a separate physical device. You can look at them like your physical laptop, right? Or a physical server, right? They kind of mimic that. So this setup provides excellent isolation and security as each virtual machine is completely independent from others. However, that comes with highly significant downsides. Running multiple virtual machines requires a substantial amount of system resources, so including CPU and memory, to handle the multiple operating systems that we have, right? This can lead to inefficiencies and increased costs, especially when we're architecting for large-scale deployments. So, what is Docker? Docker is a software for building, running, and managing containers. Docker containers emerged as a solution to several of the challenges we saw with virtual machines. But unlike virtual machines which virtualize the hardware, Docker containers virtualize at the application level, and all the Docker containers share the same operating system kernel. This allows containers to be much lighter in terms of the resource they use, as they require less memory and CPU to run. Containers can start up almost instantly and use a fraction of the resources we would have needed if we were running our applications in virtual machines, leading to better resource utilization, lower costs, and the ability to run more applications on the same hardware. Docker packages applications and their dependencies into a Docker container, and it allows for consistent operation across different environments. Docker eliminates problems where a software or an application is able to run well in one environment but encounters issues in another environment. Docker also provides a scalable alternative to traditional virtual machines, as we've seen, and this makes Docker an attractive option for developers and organizations looking to enhance efficiency and consistency when it comes to application deployment. So yeah, Docker, fancy tool, sounds cool, but really, why should I use Docker? Well, there's this famous phrase, "it works on my machine," and this phrase typically arises in software development when a program or an application behaves as expected on the developer's local computer. So as a developer, I've built an amazing feature. It actually works on my machine in my environment, but it's a Windows environment and it's not able to operate correctly when we're ready to deliver this to our end users because our server in our production environment is a Linux server and I built it in a Windows machine. This is not the only cause of this phrase, "it works on my machine." It could also be due to various factors like the software that I installed on my machine, or discrepancies in software versions, configurations that I've made on my machine, or even overlooked dependencies that are present on a developer's machine but missing elsewhere. So this phrase, "it works on my machine," actually highlights the challenges of ensuring that software behaves consistently across different environments. Again, Docker enhances application consistency, making the development and deployment of applications as seamless as possible. So with Docker, developers can be guaranteed that if they build an application and it works on their machine, it should work on any machine, and this will in turn lead to faster release cycles. Docker also provides isolation between applications, improving security and resource efficiency. And this also strengthens the security of various applications that make up a microservice architecture. In my video where I talk about what DevOps is, I discussed what a microservice architecture is, and it's a very good case for Docker. When we have microservices, even if they communicate with each other, we still want them to be solely secure, as this boosts the overall integrity of our application. Now let's look at some key Docker terminologies. We have what we call a Docker image. And a Docker image is basically a pre-configured package for creating Docker containers. A Docker image is pre-built with the necessary application settings and dependencies. Remember, we talked about dependencies. A dependency could be missed, and that could lead to an application not behaving as it should across various environments. Docker images package an application's settings and its dependencies. A Docker container is a running instance of a Docker image. It's basically a portable environment that runs a set of applications and those dependencies in isolation from another container. And we also have a Docker registry, which is basically a place where images are stored and shared. It's similar to having a library for Docker images. And there are various Docker registries out there. There's the popular Docker Hub. There's also the AWS ECR, which is AWS Elastic Container Registry, Microsoft Azure ACR, which is Azure Container Registry, and a lot more of them. So now that we know what Docker is and understand its benefits, let's see Docker in action. So we'll be installing Docker on our machines, and we'll be pulling a very simple Hello World application from Docker Hub. It's just a simple application that will print out some text, and the application will exit after doing that. But just for us to see the flow of how to pull a Docker image and how to run a container from that image. So we'll be going through these right away. So first things first, let's install Docker on our machine. So basically, all you need to do is to head over to your browser and just search for Docker installation, or install Docker, right? Then you see the link to install the Docker engine. So click on that and install the appropriate Docker engine depending on your operating system. I have Docker installed on my machine already, and we could just test an installation of Docker by running docker version in your terminal, and that should print out the Docker version and some other information about Docker client and Docker server versions and architecture. Next thing we're going to do is to pull a simple Hello World image from Docker Hub. And remember, Docker Hub is just like a library for images. So we're going to pull the Hello World Docker official image, and the command is just right beside it. But it's the same command across all Docker registries. So basically, what we need to do is pull Docker pull Hello World, enter, and the Docker engine will pull that particular image onto our local machine. So it's done already, but we can also verify that the image exists on our local machine. And what do we do for that? We basically run docker images, and we'll see the list of images running on our machine. So here you can see the Hello World image that we just pulled. Next thing that we need to do is to run a container from this image, right? To do that, you basically run docker run hello world, and if the container name were test, you run docker run test. If the container name were apple, you run docker run apple. So enter, and it prints out some text and the container exits, because basically it's a very simple application that just outputs these texts that we can see on the screen. But to also verify that our container ran, we do that by running docker ps-a. -a will show the list of all images, whether it's stopped, whether it's running, whether it's exited, whatever state it is, it will list it. So here we can see about a minute ago, we have our hello world, run, and it's exited after printing out that text. That wraps up our introduction to Docker. We've seen what Docker is, why it's used, its advantages over virtual machines, and some basic commands to get you started. In our next episode, we'll be exploring Docker files for building our custom applications. If you found this video helpful, don't forget to hit the like button, subscribe to my YouTube channel, and share your thoughts in the comment section below. I'll see you in the next video. Bye.